All right, guys, welcome to this page of the notes. Now, what we're going to do is we're going to go from beginning to end on the functions that I have given you. We're going to graph them, and since all of them are inequalities, we will be shading a solution region, the region that represents all of the points that satisfy the inequality. So here we go. Let's jump right into it with the first one. Y is less than or equal to the absolute value of x minus 1. Now, we know that what we're going to do in step number one for graphing these inequalities is going to be to graph the equation, ignore the inequality. So I'm going to graph y equals the absolute value of x minus 3. So y equals the absolute value of x minus 3. Okay, well, we know from the previous section, section 7, how to do transformations. We know that the absolute value looks like a V. And anytime I have a number inside the absolute value, that is actually going to be my H. So I know that H is equal to a negative 3. And I also remember from that section that when it comes to the horizontal shift, which is what H is, whatever the sign of H, I actually go in the opposite direction. So this is going to be a horizontal shift 3 units in the positive direction. 1, 2, 3. And my V is going to go right here. Still going to open up because A is positive. I don't have a K, so there's no vertical shift. I'm just going to shift my V right over to this point right over here. There's my V represented by the graph that I was given. Now in step number 2, I need to figure out, do I have a solid or a dotted line? So now we go back to the inequality. I have y is less than or equal to. Well, I remember that less than or equal to means a solid line. So less than or equal to means solid. I need a solid line. Okay, which I already have. I've got a solid line. Step number 3, I need to pick a test point. All right, well, let's go ahead and pick a test point. Let me do my test point in green. My V does not go through 0, 0. So this is going to be a perfect opportunity to use 0, 0. This point right here as my test point. Let me write down so you guys know I am using 0, 0 as my test point. Step number 4 says plug it into the original equation to figure out if you get a true or a false statement. Well, let's go ahead and do that. If I plug a 0 in for y and a 0 in for x, 0, 0, right? That's what x and y are. Well, here's what I get. 0 minus 3 is a negative 3. I take the absolute value of a negative 3, I get a positive 3, and that means I have 0 is less than or equal to a positive 3. Well, is that a true or false statement? Yeah, it's true. That's true. And what step number 4 tells us is that if my test point gives me a true statement, that means it represents the solution region. Well, here's how the graph is going to be divided. There's all the points inside the V. There's all the points outside the V. And since my test point was outside the V, that's my solution region. I will shade everybody outside of the V. This represents my solution region. Everybody on the outside of the V. Great. Let's go ahead. I'll erase this and let's try the next one. Okay, so now that we've done one with absolute value, the next one we're going to do, taking a look at that next one, is it represents a linear function, right? It's not absolute value. It is y is strictly less than 2x minus 3. Now, the nice thing about this linear function is it is already written in slope-intercept form. So let's just go ahead and graph this guy. Easy peasy. Using my slope and my y-intercept, I'm going to graph y is equal to 2x minus 3, where m is equal to a positive 2 and b is equal to a negative 3. Right? 2 is my slope, b is my negative 3. Hang on, that's a terrible 2. There we go. Okay, so I am going to graph my y-intercept, which is at negative 3. 1, 2, 3, right about there. And then I'm going to use my slope, which is 2 over 1. That's up 2, 1, 2 over 1. Get a couple more, up 2 over 1, up 2 over 1. I could also go down 2 and back 1. That's the exact same thing, down 2, back 1. In fact, it just works so well, let's do it again. Down 2, back 1. Works so well, do it again. Down 2, back 1. Connect all of your points with a solid line. Make sure you extend your line all the way through the coordinate plane I've given you, putting arrows on both ends of the line so I know you know that that line just keeps going. Awesome, I've graphed my line. Step number 2. Do I need a solid or dotted line? Well, the inequality is less than or equal to, so we know that that means a solid line. Okay. Step number 3. I need to choose a test point. Yep, absolutely. My line does not go through 0, 0, so here we go. We're going to pick that point right there, 0, 0, and let's plug it in. So I'm going to have 0, 0 as my test point. I'm going to plug a 0 in for y. I'm going to plug a 0 in for x, and here's what I get. I get 0 is less than or equal to. 2 times 0 is 0. 0 minus 3 is a negative 3. All right, here we go. The question is this a true or a false statement? Is 0 less than or equal to a negative 3? No. No, it is not. So that means that my test point gives me a false statement. This is not true. This does not represent a solution. Since my test point is above the line and it's false, I need everybody on the opposite side. That means everybody down here will be true. So I'm going to go ahead and shade everybody on the opposite side of the test point. Because my test point was a false statement, it is not a solution. I need everybody on the other side of the line, because everybody down here will be true. If everybody above is false, then everybody below will be true, and I'm looking for all of the solutions that satisfy the equation, all of the solutions that are true, or give me a true statement. That'll be everybody below. Fantastic. Let's go ahead and try another one. The next one I've got for you is actually an equation written. You should recognize it as standard form. And as nice and pretty as standard form is when it comes to a linear function, it does us absolutely no good when it comes to graphing. In fact, it is less than useless. It looks nice, but it doesn't tell us anything when it comes to graphing. So I need to do a little bit of work. I need to solve this equation for y, which I can easily do by subtracting the 2x to the other side. So here we go. I need to graph. Step number 1. I need to graph the equation y equals. I'm going to subtract the 2x to the other side. That's going to give me a negative 2x plus 6 minus 2x. Okay, find my slope and my y-intercept. Well, my slope appears to be a negative 2. And my y-intercept appears to be a positive 6. So let's go ahead and graph this. I need to be at positive 6. 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5, 6 right there. I have a slope of -2. That's going to be down 2 and over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. I could also go up 2 and back 1. Up 2 and back 1. In fact, it works so well, let's do it again. Awesome, so there I go. I got a bunch of points. I'll connect those guys with a line in a second. But I come back to my equation because I know now in step number 2, I need to figure out, do I need a solid or a dotted line? Well, my inequality is greater than, strictly greater than, which means that I will need a dotted line. So when I go ahead and connect these points, I'm going to do so with a dotted line. Make sure you extend your dotted line all the way through the coordinate plane, putting arrows on the ends of your dotted line so that I know you know that that dotted line just keeps going all the way through. All right, so that takes care of the graphing it. Now let's go ahead, step number 3, and figure out a test point. Well, I'm going to check and see, do I go through the point 0, 0? I don't, and again, most of the time it will not. So we're definitely going to go with 0, 0. Let's find out if that gives me a true or a false statement. So in step number 4, we're going to plug that stuff in. Let's see here. I plug in a 0 for x. I plug in a 0 for y, and here we go. 0 times 2 is 0. 0 plus 0 is 0, and I wind up with 0 is greater than 6. Well, is 0 greater than 6? No, it's not. I get a false statement. And since my test point, and now this is up to you, right? Do you consider that to be below the line, or do you consider that to be to the left of the line? Whatever, your test point is on this side of the line, and it gave you a false statement. That means your solutions are on the opposite side. So we're going to shade everybody over here. Shade everybody on the opposite side of the line. Since my test point was false, it is not a solution. That means everybody on the other side will be. Fantastic. Let's go ahead and do another one. Again, I've given you the equation in standard form, which is no good. We're going to go ahead and need to, we will need to change it, put it in slope-intercept form. That way I can graph the equation. Actually, it doesn't look like, hang on, is my line? Let's see if my stuff is going to erase. Oh, there we go. There it goes. Come on. Okay, sorry. For some reason that stuff is not erasing. That's okay. Let me slide this up a little bit. I'll do it in a different color. Hopefully that'll. My iPad is working really, really slow today. Terrible, terrible. Let me do it in a different color. So I'll go ahead and do this one in green. So in green, step number 1. I need to graph, first of all, the equation. So I need to solve this guy for y. Actually, I apologize. I told you it was in standard form. I lied. It is not in standard form. This is in slope-intercept form. Go ahead and flip this guy around. I have y is less than, it'll be 3x minus 4. Y is less than 3x minus 4. Hang on, that doesn't really look like a less than sign. Okay, now I need to graph the equation. So y is equal to 3x minus 4. And now it's pretty easy to see. M is a positive 3 and B is a negative 4. Yeah. All right, so I should be able to graph this. Let's go to negative 4. 1, 2, 3, right there. with a slope of positive 3. That's up 3. 1, 2, 3 over 1. Up 3 over 1. Up 3 over 1. Or I could go down 3 and back 1. Worked so well. Let's do it again. Down 3 and back 1. All right, now I need to figure out dotted. It's going to be a dotted line, number 2. Dotted. So let's put a dotted line in here. Again, sorry, I apologize that that red line is in there. It shouldn't be there. Just ignore it for now. I'm not sure why it's not erasing. So anyway, I've got my dotted line. And once again, I can choose a test point. 0, 0 is absolutely going to work. My line does not go through 0, 0, so I'm going to use that. So step number 3, I'm going to choose 0, 0. And I'm going to plug that in for x and y. So 0 and 0. Well, here's what I've got. 3 times 0 is 0. 0 minus 4 is going to be a negative 4. And I have that that is greater than 0. Well, is negative 4 greater than 0? No, it's not. That is false. False statement. So that means I need to shade everybody on the opposite side of the line. Since my test point is to the left of the line, I'll shade everybody to the right of the line, everybody over here on this side. And that'll give me my shaded, or my solution region. Everybody over here on this side of the line will be my solution region. All right, we have one more to do, another absolute value one. So let's go ahead and do this last one. And you guys should then be fairly comfortable with graphing these inequalities. So here we go, one more. Again, when it comes to these inequalities, especially the absolute value ones, we should be able to use our transformations from section 7, right? A, H, and K to help us graph it. So let's go ahead and do that. I am going to graph, let me do it in green again. I'm going to graph the equation y is equal to the absolute value of x minus 2 plus 1. All right, let's find A, H, and K. All right, well, if I have an A, if there's an A, there'll be something in front of the absolute value sign. And there isn't anything, let me fix my absolute value sign so you can tell it's absolute value, absolute value, absolute value. There should be something in front of my absolute value sign, and there isn't. There's just a positive 1 out there. And we said that a positive 1 doesn't do anything to the dilation of the graph. We'll multiply anything by 1, it's itself. So 1 doesn't change anything. So my A is just going to be a positive 1, and that doesn't do anything to transform the graph. Then I try to find an H. Well, if I have an H, it'll be inside the absolute value, and I do. I have a negative 2 in there. Negative 2. Well, what that does is we know that it is a horizontal shift in the opposite direction of the sign of H. Since H is negative, I will go in the positive direction 2 units. And if I have a K, let me fix that. It doesn't quite look like a K. If I have a K value, it'll be hanging out back here, and there is. It's a plus 1. And we know that K is going to be a vertical shift up, right? Because K works exactly the way that we want it to. So my graph is going to look like a V that has been shifted to the right 2 units and shifted up 1 unit. Let me get rid of my test point and put in my new graph. Here we go. I need a V shifted over 2. So it's going to be here and then shifted up 1. So my V is going to start right here. That's shifted over 2, shifted up 1, and this is where my V is going to start. There is no dilation, so it'll just be a standard V. And And my V will be opening up because my A is positive, right? If this were negative out here, then it would open down, but I don't have that, so here's my V. Also, I need a dotted line, right? My V is strictly less than, so I need a line of